ad-lib it. My name's Max. This is Lab 8 Laser. Our TAs are Carter and Samar, and yeah, I go to the University of Arizona.
And my name's Haley Watts. This is Lab 8. Our TAs are Carter and Samar, and my favorite color is gray.
Mine's purple. Wait, it's gray? That's
yeah.
Part A. Use this green laser to align the system, make sure it's all on axis. Then we turn it off. Turn on the helium neon laser. Then you can see this red laser is produced by the helium and neon because it's reflected back. Then adjusting the tip tilt here, we can get a different number of modes, which is pretty cool, and we're trying to max it out. We're going to throw this fiber in here too and max it out. So thank you.
So this is for part B, and what we first had to do is we had to align the laser throughout this optical system so it hit the detector. And in this detector you see there is a little we call it aperture that you can open and close, so we had to open that so that we would get a signal here. And we used the signal for the oscilloscope so we could find our peak-to-peak values and our different spacings for our two modes. So as you can see, there's a smaller mode and a larger mode. Divided our larger peak-to-peak value by our spacing between modes and multiplied that by our frequency of our detector, which was 10, so we got around a longitudinal mode spacing of 10. We also looked at the polarizer and determined that the light was polarized because the light was dimming as we were rotating the polarizer. So this is part C. For part C, what we're going to be doing is we're going to be aligning our helium neon laser and the laser diode into the optical spectrum analyzer. And what we're going to be seeing is we're going to see a graph, and we're going to find our primary mode peak, and we will find the wavelength that it's at, its width, and if any other modes are there, which we can see that that one has a secondary mode, and we will see the separation of those modes.
Let's go!
So we're trying to find the length of our laser cavity. So we're going to do a test run by just measuring like this, and then using the ESA, we're going to find the difference of the frequencies and use the equation F equals C over 2L, and then compare the two results. Probably using the frequency, this will be shorter than the actual physical boundary.